Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to learn about how to size the off-grid solar PV system. So essentially we are going to find what size of solar panels and what size of the battery we need to install in off-grid solar PV system. Also about what size of inverters. So inverter size, battery size and the solar panel size. These three sizes are important, the ratings, what kilowatt rating of these appliances need to be installed. It is very important. So this is we are talking about off-grid system. So please go and watch the video about the off-grid system. Off-grid system means we are not connected to the grid. We are completely independent from the grid. So those kind of system, how we can uh, uh, account or measure the total power consumption in our house or the industry, then we can supply our own electricity demand. So the concept is off grid means we are generating power and we are supplying to our own usage, own demand. So we are not depend on any other grid, and we are also not selling to the grid. So whatever we are generating, we are going to use it. So this is more applicable to small factories. So they are sometime can run as off grid. They can generate the power and they can generate electricity and they can supply to their own demand. And some remote area houses, like houses located in a little bit of remote area, so instead of connecting with the grid, they can choose to operate as off grid. So let's go into the calculation. The first step is always we need to find what is the energy usage consumption in our house. I'm taking a house so it's easy to explain. So house or factory or whatever. So for that, like we are not sure exactly, we need the everyday average demand. But how we can find the daily demand, because we don't have a daily data. We don't have a data how much power our house is consuming every day. So what we have is every month. That data we can get from the electricity bills. So the units, how much units this month, January month, how much units February month, March, likewise we can get. So the accurate procedure is the best practice is that always uh, add all the units consumed by your house for entire year, that we are doing here, that you account for all the years energy usage, add everything and find the value. This is a yearly energy usage, then divide it by 12 to get the monthly energy usage. Then again it's divided by 30 days to get the daily energy usage. So this value is important to carry out our calculation. This 4 kilowatt hour is important to carry out our calculation. So what we need, essentially we need the electricity bill for last 12 months. Okay, this is a best practice, but some people, if they don't have last 12 months electricity bill, they do some other measures. I will tell you the next slide. So if you don't have an electricity bill, what we can do, then we can assume, reasonably assume how much electricity going to use by your house, what is the energy consumption. So here the assumption we put 10, we have 10 lights and each light's running at 6 hours per day, and we have one TV is running 1 hour per day, we have one washing machine running 1 hour per day. This is the assumption, one rice cooker running 1 hour per day. Likewise, we can assume and we can find the kilowatt hour per day. In a day, average, how much is going. It cannot be accurate, but it can come closer to our actual value. That's why this is coming 3.96, the previous value coming 4 kilowatt hour. So this is reasonably okay. And then one more step, this is if you don't have electricity bill, you had to do this. And this step, the power, this here we are measuring the power here, 10 watts, 60 watts, 100 watts. We are adding all the appliances we have in the house and saying that 2450 watts a total power rating at a particular time. if you turn on all the appliances. This is very important for the inverter design. Why means the inverter has to design for the to manage the maximum power. So what is the idea here? I mean, when the maximum power uh, consumed by the house, inverter can able to supply that maximum power. What is the maximum power here? Is 2.45 kilowatt. At a time, if you turn on all the appliances, you need 2.45 kilowatt. Okay, this is the next thing. Okay, I'll go to one by one. We go a little slowly because it's a calculation. Next thing, many people do not many people. Some people do in a wrong way when they calculating, because after they finding the energy consumption, they go for a solar PV size. So the second step is not the solar PV size. Second step is calculate the size of the battery, because this is an off-grid system. When we talk about off-grid system, battery is going to play a major role in the off-grid system. Off-grid system is depend on the battery energy storage. Let's think a simple scenario. You in the daytime you are generating solar power electricity from solar panels. In the night time you don't have any electricity at all. So what you are doing in the daytime, you store in the battery and you are running your house in the night time using the battery energy. So battery is the main player here. So even in the daytime, let's say suddenly we have a raining coming for too few hours, or cloudy weather coming suddenly, then what happens? Solar panel is not going to produce any electricity. Your battery going to supply the power to the house. So in the essence, battery is a major player. So next step is to size the battery. Then we can size the solar panels later. First thing, find the appropriate size of the battery. So here, how we can find the size of the battery? Because what is the total power energy required per day? That is 4 kilowatt hour. We calculated from the electricity bills. And days of autonomy. Days of autonomy means like how many days we are going to supply the power using the battery. So days of autonomy, we are going to decide if we have more money on our hand, or if we have we experience more weather problems, so we are having a lot of cloudy days in between, then we have to increase the days of autonomy. Days of autonomy mean if solar panels not producing power, how many days this battery can supply power to the house. So without depending on the solar panels, battery alone can supply to the house. How many days? How many days battery alone can supply to the house? That is the days of autonomy. Autonomy mean autonomous. So in English words, autonomous mean we are running independently. It's autonomous mean that is a general meaning. From that general meaning, days of autonomy mean we assume 2 days. We give 2 days. Usually people take 2 days. This means if let's say next 2 days there is no sunlight, no solar power production, solar panel not producing any electricity, now this battery will supply for 2 days, day and night, the days of autonomy. Next 48 hours battery will supply power. The third day battery cannot supply. That is a logic. Okay, so here then the depth of discharge, we have to divide by depth of discharge. Usually we assume the values depth of discharge depend on the type of battery. Is a lithium ion battery or lead acid battery. Lead acid battery mean depth of discharge is very low, about 0.5. We are taking lithium ion battery, is the advanced battery, so it's 90%. And the battery efficiency also we can put 90% because taking a advanced batteries. Okay, lithium ion batteries. Okay, with that, we found the size of the battery, that is 988 watt hour. So we found the size of the battery. Now we found the size of the battery. We need 9880 watt hour battery size. Now batteries are sized in amp hour, not in watt hour. So we need to find what is the amp hour. So we had to divide by the battery voltage. For this size battery, it's a good to have a 48 voltage battery. Okay, we can have a 24 voltage battery as well. So if we use a 48 volt reasonable, we need a 205.8 amp hour. So we can approximate it to 200 hour amp hour. It's fine because we can leave that 5 amp hour. It's not a problem because these calculations are, I always saying that it is not 100% perfect. We can adjust few values because these are assumption. We make a lot of assumption. Why I'm saying assumption, instead of 0.90, I can, if I put 0.95, the depth of discharge, it's different answer. If I put 0.85, we get different values. So these are the reasonable assumption. We are making reasonable assumption, so that values here. So if you want to use 24 voltage battery, sometimes people want to use two number of 24 voltage battery because sometimes because of the cost, cheap price, cheap, then we had to have two number of 24 voltage battery, each having 200 amp hour. So this is a reasonable size of the battery. Okay, we go to the next slides. Next slides calculate the size of the solar panel. Now we are coming to find the size of the solar panel. So how we are going to find the size of the solar panel? Because as I said, the off-grid system, charging the battery is a very important thing. So in order to charge this battery, what size of solar panel we need? So we have the battery size. This battery size is 9880 watt hour, and we have a peak sun hour. We assume peak sun hour is 5 hours. Peak sun hour mean, in the meteorology department we can find peak sun hour mean in average every day how many hours the sunlight is coming usable for I mean how many days we are getting the sun solar radiation that is producing the rated power output from solar panels. So solar panels producing rated power output for how many hours in a day. So best assumption is 5 hours. 5 hours it is giving a rated, it's average value, because if we take this average, most of the confusion coming in the solar radiation related problem, I mean rainy days, cloudy days, everything is averaged. So this is if you take 5 hours per day, your whatever your rainy days, cloudy days, everything will be averaged 5 to 6 hours. Some places they say 5 to 6 hours, some people take 4.5 hours. It depends on your location. Okay, then system efficiency. Okay, the solar panel system efficiency 0.73 we put. Why we put 0.73? It's here, system efficiency is here, because system efficiency solar the entire system PV system efficiency depend on the battery efficiency, inverter efficiency, and efficiency of the component. Because all efficiency loss is we have to produce more power in from solar panels to cater these losses, these gears. Efficiency mean, in other words, we are going to lose some value, some energy in the cables. Let's say 0.85 percentage mean 15 percentage of energy we are going to, whatever solar panels produce, going to be wasted in the cable, the wiring loss, I square R loss, and 5% is going to be lost in the inverter, 10% is going to be lost in the batteries. So we need to account all this value, then divide by this, so that we can produce more power to manage our 9880 watt hour battery size. Okay, so then we get 2700 watt. This is the watt value we are getting as a panel size. So usually if we have this kind of number, we go for little higher. So we go 3000 watts panel. This is advisable. Some people even go for 2750 watts panel. It's fine, but usually designers giving a better you go for 3 kilowatts panel, because in future you may add more loads. Okay, some people go for exactly that 2750 watt panel. That's also okay, but as a consultant, what I can recommend, go for a little higher size of the panel, because in future your load demand increases. In future, when battery is running for a longer time, efficiency going down, battery efficiency going down, inverter efficiency going down, there are many losses may occur in after 1 or 2 years. I mean, when the system is running, the losses increases. because of the particles, and solar panels will not produce a lot of the rated power because of the shading issues, particle on the panels. So all because of this reason we go for little higher value. So now we found the panel size as 3 kilowatt panel. Okay, now a common rule. Now the question is, what's voltage we need to get from the solar panels? So the good rule of thumb is like 1000 watts. If our system is less than 1000 watts, we can go for 12 voltage solar panels. If it is 1000 to 3000 watts, we go for 24 voltage system. If 3000 or more, we can go for 48 voltage system. So for this case, we can either go for 24 voltage system, or we can go for 48 voltage system. This is because in this equation P is equal to V into I. If the power is increasing, like 5000 watts or 4000 watts, we cannot keep on increasing the voltage. We have to increase the sorry, we cannot keep on increasing current. We have to increase the voltage as well. So if we increase the voltage only, we can get the appropriate power, because we cannot increase the current for higher value, because current, if we increase the current for higher value, then we need large cable size. The cable size become large. If the cable size become large, the installation cost is high, the material cost is high, the total project cost is high. So the idea here is, we try to, in electricity, we always try to make the current a minimum value, low value. We don't want current to be increased, but we are okay with increasing the voltage. We are okay with increasing the voltage, but don't want current to be increased. Okay, that is the idea here. Okay, so now the calculate inverter size. Next thing, we need to calculate the inverter size. So inverter size is always depend on the peak demand. Peak demand, as we calculated, that is 2.45 kilowatt. Peak demand, how we can find the peak demand means, when we turn on all the appliances, what is the the demand we are getting? That is a peak demand. And we have a safety factor. That safety factor, why we have safety factor? Because according to the National Electrical uh, 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 code, a national electrical code, we had to use the 25 to 30 percentage of the safety factor. Why we are using safety factor? Because in future you may add more load, you may add another air conditioner, another fan, another cooking appliances, so the load may increase. So the inverter should support the increasing of load, and this is called safety factor. Because one of the reason is this, another reason is that if suddenly load demand increases, so for some cases the inverter has to supply that. So we found a 3.2 kilowatts inverter is suitable for this. Okay, we have a 3.2 kilowatts inverter. Then we need to find the charge controller. The charge controller, how we can find the charge controller? Solar panel power rating divided by battery bank voltage, because charge controller going to take care about the battery. So charge controller size here, 3000 watts our panel, and the battery we choose 48 volt, so that we get 62.5 amps. Instead of 48 volt, if you take the 28 volt voltage battery, for some reason, for the cost benefit, low cost or some reason, the become 24, and you get the 125 amps, the charge controller current. But this 125 is higher value, so my recommendation is to take the 48 voltage battery, because the problem is 125 is a high current. So then the charge controller size is high, and again cable size we need to be high. So we, in electrical engineering, we don't want to increase the current in power system, especially because if increasing the current always causes more cost, because more spending, because we need a large size of wires, we need the large size of breakers, safety equipments. That's why we don't want to increase. So far we calculate the most of the things. Okay, so let's come to the next one, is the breaker size. Okay, solar, what is breaker size? We have to find the solar panel size and the voltage. This is a 48 voltage. We are getting the breakers 62.5 ampere, but we are using the breaker, the factor. We always use this factor to find the breaker size is about 78.1. We can take the 80 ampere breaker. So breaker size essentially is saying, is doing like when a solar panel is producing the maximum power output, what is the current? If I get more than that current, it's something wrong. During the lighting strike or anything, we get more current, so the breaker will trip. The essential logic is, what is the maximum current I will get from the solar panels during the peak performance? I mean the maximum performance. If we get 1.525 percentage more than that, then it is something wrong. Little more than is okay. 5% more than that is fine. That is the logic. Even 10% more than the maximum current rated current, what manufacturer says that this will be 62.5 ampere. Okay, if we get more than that, that's a problem. Okay, then breaker trip. Okay, we come to the final slides of summary. We find the panel size. First we found the battery size. Okay, first we found the actually energy consumption is 4 kilowatt hour per day. That is the our data. This is the input data. Based on this data only, we find all the values. And the peak demand is something like 2.45 45 kilowatt is at peak demand. So these two are the data. These are the data. This is data for the inverter. This is the data for to find the inverter size. This is the data to find all other size. Okay. So we found 3 kilowatt. First we found the battery size, 200 amp hour, 24 voltage battery, or 400 amp hour. Sorry for this, 24 voltage battery, or 400 amp hour, 48 voltage battery. Okay, and we found the charge controller size, we found the DC circuit breaker size, and we found the panel size. So this is a summary. So there are different assumption taking by different solar companies or different installers. If you go, you can verify whatever I'm teaching, you can verify with the current practices, and you go to, when you are really installing the system, you can ask the solar company to come up with a design like this. So they will suggest what size of inverter you have to install, they will suggest what size of solar panels you need. Then you can ask like why you choose this size of panels, what's this size of battery, they will explain. Then you can compare that explanation with what I am explaining, because there are different standard they are following, like not standard actually there is no certain standard here. It's because we cannot exactly size the solar panels and batteries, because it's depend or heavily depend on power production is heavily depend on weather. The weather is fluctuating. Okay, so weather is fluctuating. The 5 hours average daily sun hour is also is a questionable. For let's say the next year we have lot of rainy days. Like next year is going to be a worst year in terms of weather. A lot of raining, cloudy, and a lot of wind flow. Now this next year, will I get a 5 hours average solar radiation is a question. Because of climate change, things are changing, so taking the average is questionable. That's why there are a lot of research going on and predicting the weather, predicting the solar radiation, predicting the solar temperature, predicting the wind speed. So what will be next year scenario? Likewise, a lot of researches are going on. So all biases is there, but I'm saying there are a lot of biases here in this design. But with what we can do is, by using the data, available data, we can find the size of reasonable size of the system. Okay, thank you very much. Please subscribe this channel and provide your support, then only I can provide this kind of videos. Thank you. See you in the next video.